Okay, hello everyone from probably the other side of the world for most of you. I'm in California, and I come to you giving you a short presentation of some great open source projects, including WebThings, where I'm going to give you a tour of my home, how I can maintain a smart home that's all private to me, or as much as possible private to me. So let's see, how do I advance my slides? Sorry, didn't do the presentation. Oh, there we go, right there, the right arrow. Okay, so just a little bit about me. So I've been in the technology industry for a really long time. I came out here to go to grad school and ended up, my first job was like Fortran data analysis of electric field mills, doing all sorts of cool stuff. I've just been involved in doing things with, you know, Linux and tools and open source for a very long time. And more recently, I'm trying to spend a lot of my volunteer time applying open source technology into the education space. So I'm going to be showing you a little bit about a great project we call Microblocks, which was developed by the founder of, one of the founders of Scratch. And it's how you can do physical computing with a blocks-based language. And it actually applies really well to the Internet of Things, because anything with connectivity can be turned into what we call a web thing. Now, I'm going to skip the boring introduction about myself because the first thing I want to do is take you through some of the parameters of why privacy and security are important. I'm sure you all understand that, but basically I wrote down on this slide the concerns I have for my own home, which is, you know, security. I don't want hackers being able to attack me like they did the Colonial Pipeline recently. You know, you don't want cyber attacks. Privacy, that's like super important to me. Not as important to everyone, but for me, just when a door opens and closes, when there's motion in the home, when there's network presence of the devices in the home, when lights are switched on and off, all of that type of information is really a blueprint for when people are home, when a home is occupied or not. And if that information were stored in the cloud and somehow hacked, and millions of homes, you know, tens of millions of homes had occupancy data, that would be a great, you know, dark web data set for someone to know, you know, what if you come and go for work and when to break into your home or not. I mean, that, to me, that's just the tip of the iceberg. There's all sorts of privacy concerns I have, but, you know, mainly it's just like, you don't want to live in a glass house, right? And by exposing all your data, that's what you're doing. The other third main problem of smart home is interoperability. Like, you can buy into one system and use that system for everything you do, but you're kind of stuck on what that vendor offers you. And it's really hard to do your own thing or mix and match or grow it over time. So what I'm going to be demonstrating today really is a growth of something over time. I didn't like put it all together in one fell swoop. And lastly, at least for me, if I hadn't worked at Mozilla on the WebThings project and gotten my hands on a lot of different smart home devices and really got intimate about how they worked and which ones, you know, connect over a radio that's non-IP protocol like Zigbee or Z-Wave, connect only to my device. If I wasn't like doing that full time as a job, when would I ever have had the time to research all the different devices out there, all the different systems and tools? So in addition to having some, you know, interoperability and ease of use, I think the overall value is to consumers to help them understand what devices are easy to use and why, what ones protect your privacy or not. You know, those kinds of things is something we need to wrap into the whole system. So what I'm showing you today is definitely a, you know, a developer-centric view of things, but it has commercial implications. One of the main differences in the approach we took with the WebThings project at Mozilla, which is right now, by the way, a community project. So if you want to get ahead of myself, WebThings.io in one of the tabs, and you can look up the project. Basically, my home runs on a Raspberry Pi. In this case, the data center is the Raspberry Pi in my house. And so your home is your data center. And you only use the cloud, for example, to access from your smart home, you know, the web interface, oops, so that when you're away from home, you can still monitor, and that tunnels through the internet over HTTPS. So it's HTTPS access only. Instead, a typical vendor, and this is just a web page, a progressive web app that I have, you know, as an icon on my desktop. So I just click the icon and I'm right in the app. Otherwise, I have loads of apps that I've had to download just for the initial installation of, for example, Wi-Fi devices. And if you have this system of all these different vendors, you end up with hundreds of like different apps, and interoperability between them becomes very cumbersome. All right. So those are some of the problems. Looking at interoperability itself, what the Web of Things does is there's a standards body group called in the W3C called the Web of Things, which this project is based on. And it just says all we're going to do is we're going to tie all these different protocols, all these different messaging methods. We're going to put them all together at the web layer so that web services, JSON definitions essentially, describe these different things. And they have actions, events, and properties. Properties being the main thing. And so new technology coming along, the one that was called Connected Home over IP is now renamed to Matter. And I think Zigbee was renamed to something else recently. But it doesn't really matter. You can bring them all together. And so your own private home consists of sort of this WebThings Gateway, things that you buy. You can also build things. And then you just manage it all under one roof, essentially. And I wrote a tutorial that really needs to be updated because it's still got Mozilla branding all over it. But there is information on the wiki, the WebThings framework. There's all sorts of libraries that take, that give you in different languages ways to create web things out of data. You know, everything from Arduino and Microblocks to you know, Python and JavaScript and Rust even. And then Microblocks, like I said, is what I use to program microcontrollers typically. And I can turn these things into web things with just the addition of a library and a few additional blocks that say, you know, I have a temperature property, and it shows me the degrees Celsius or Fahrenheit or whatever I want. Microblocks.fun is another tab to open up on your browser. And just to show you a little bit behind the scenes, when I open the Microblocks IDE, I get a library list and I have the capabilities, the properties, actions, and events. Actually, it only does properties and events in this library. And then I can create smart lights, smart motion sensors, door sensors, temperature sensors, and all I have to do is pull the blocks together. And behind those blocks, so all I have to do is behind the blocks is the actual on. And so I can turn one of these microbit boards really easily into a smart light, into, you know, it has an onboard motion sensor, could be a smart motion sensor. And these extra blocks in red are the WebThings blocks. And all it's doing in this case is I could use a button to toggle the light on and off with the actual device, or with my web browser, I just toggle the icon on and off. And I didn't have to build a web page because the Raspberry Pi does that. And the blocks on WebThings do the rest. So IoT for education becomes really easy. Now, extending an alternative to the WebThings Gateway would be to use something like Snap, where you can just build your own user interface. And Snap is another blocks-based language that runs on your laptop through browser, and it's just awesome and amazing. snap.berkeley.edu. And just a little hint about how Microblocks actually works is these blocks are actually the programs that are running. Behind them, there's these opcodes that turn into machine code that actually runs on the bare metal of the microcontroller. So there's actually a virtual machine that is running the blocks. And then when you disconnect the microcontroller from your laptop, the blocks are still running in the microcontroller. So it does run and fully autonomously in an untethered situation. So it really is a fantastic language compared to something like Arduino, which I've worked for and used in the past. This is so much better. And there's a virtual machine to build for all these different microcontrollers. We use Platform.io as the tool for that because it's just phenomenal for any text-based framework that you want to build for microcontrollers. So if you clone the Git repository, you can build microblocks for whatever boards are supported, which is in the platform.io ini file. Just this picture, you'll see I have some online demos on my YouTube account, something about IoT and privacy. There's a Raspberry Pi and a speaker and speaker microphone. I'm going to demonstrate that live, so I'm not going to show this video. That's sitting over in the other room. And then the WebThings links, just going to show you a few links here. WebThings.io is sort of the starting point for that. I have some YouTube playlists for both microblocks and IoT, and I can share this entire presentation. There's, if you subscribe to Make Magazine, or you can just go to the online version of Make Magazine and get it for free. Issues 72 and 74, if I remember correctly. One has the WebThings article I wrote, and one has the microblocks article and all the different microcontrollers you can use. And if you want to get involved, this just has a bunch of information about how to contact me, and my Twitter and LinkedIn handles. And then just to note that the other thing I love about open source and community-driven projects is that early on I pushed hard to get WebThings translation into the project. The same tools, Pontoon and Fluent for translating Firefox are the same tools used to translate WebThings. So you can convert WebThings from just picking your language, and the translators wanted for all these different languages. For microblocks, the translation is a little different. There's just that sort of the one language, like English, translate to another language, and then once that's available, you can also change the IDE to many different languages. So this was a summary of like microblocks, WebThings, platform.io, Snap, 4 great, awesome open source projects with really excellent educational potential, I feel. And there's one more that I wanted to introduce for 2 reasons. One is that I started working for a commercial company that takes advantage of this Linux Foundation open source project. And the second thing, like there's a big example of it lately, the Colonial Pipeline in the east coast of the United States. They're having all sorts of gas shortage issues with people hoarding gas because there was a cyber attack on this Colonial Pipeline. And so the next project, what it aims to do is to take embedded Linux products that are deployed at the edge and make a secure conduit to the cloud for them. And rather than sort of, worrying about lots of different Linux distros and lots of different applications running at the edge, there's a Linux Foundation project called Ide for sort of for a virtualization or containerized approach to the edge, where you have the thinnest shim of a Linux kernel running on hardware, and it basically does all the virtualization. It utilizes Alpines, which is really supposed to be a thin shim, and then you deploy applications through the secure conduit, and only the controller conduit can run them. So I really do have pretty good faith that we'll be able to stop some of these cyber attacks that are occurring because of all of these exposed edge IoT devices. And this project you can find on Linux Foundation and then on GitHub. And there's an open source implementation where Eve has an OS version that runs on the edge, and then you can use a command line controller, or there's a commercial instance at the company I'm currently contracted for called Zidata. And so you find that as a Linux Foundation. So that's another great project for sort of the security and privacy around IoT. Now, on the demo side, I'm going to focus on 2 things. First, Smartthings, I keep promising. And secondly, I'm going to spend a little time on the microblocks side, so you can see how cool it is to be able to program, microcontrollers and turn them into physical computing devices, and if they have connectivity, IoT devices. So without further ado, I'm going to share my screen. And I don't know if don't know if it's going to be possible to minimize the slides then. So I want to close this. There we go. Look at that. Now you're seeing my web browser. Okay, so the first thing I want to do here is, I need to open this window so I can actually see it. Okay, so this is what I'm sharing. What I want to show you is this is just an interface of either virtual objects or real objects. In the case of an IP camera, I have one that points outside the front door of my home, and it looks, you know, out at the front sidewalk. You can see cars in the driveway or on the street. Helps you see that. And that's just, again, snapshotted through the browser. These are sensors that are air quality sensors that come through an add-on. So the whole framework of this Web of Things is that there's a core, you know, JavaScript object notation for defining all these things in a standard way. But then once they are represented, then any object, you can open up its splat icon and see the details, and you can see various information about it. And so this, you know, air quality sensor is actually within a kilometer of my house, but it's not my air quality sensor. It's something I've pulled in the data from the internet, and so I can use it to determine when to close my windows and doors in the summer when there's wildfires in the area, which has been a problem lately. And this exact add-on, the air quality purpleair.com add-on, was a request by me, and a developer in Germany actually put it together in a day to help me know when to close my windows and doors. And so I have a rule of an upstairs screen door that if it's open in the middle of the night and the air quality, like the wind shifts directions, the air quality goes into the bad, unhealthy range, then I have the little speaker alert me and wake me up in the middle of the night, even 3 a.m., and I close the door, and all I have to do is close the door, and the rule will change to stop saying that. So if I actually go into the rules here, the beauty of it, again, of being all in one place, is that then I have rules to tell me, okay, so bad air if door open. So if I look at that rule, what I was just describing, when the air quality goes above a certain amount and the upper deck door is open and it's an even minute, it's going to alert me with bad air until I reset, you know, until the air quality goes lower, or I close. Basically, all I have to do is close the door. So that's really cool. And then what I said, you know, about the beauty of the add-ons, before I take you around on tour, I just wanted to show you how that works. So there's rules for all of this, tying things together. There's logging. So I just want to quickly show you what that means. So, you know, when the entry door was, you know, open and closed, some motion in the TV area, which is near the kitchen area, when the front door was open, things like that. So there's all sorts of temperatures and earthquakes and motions and tides and air quality. And so all of this stuff is logged for 7 days over a period of time. And then I also have it laid out over a floor plan if I want to do floor plan view, but I have so many things now that I tend to use the other view. And then just so you know, this is a Raspberry Pi connected on the Wi-Fi network. You could also plug it in over Ethernet. The domain is something you set on your own, so you have your own private domain. I'm actually connected locally, not through the internet right now. So the whole system actually works without internet access. It all runs locally. If my internet broadband is down, my local network will still continue to function. My users is as many as I want for logging in. The localization, as I mentioned before, is just going to be for date, time, rules and parameters, and then the languages. Pick your language there, and then also pick your units of whether you want imperial or Celsius units. I always use metric. So going back, experiments, there's developer things like you can go into the detailed logs, create authorizations, and whether you want to enable SSH into your Pi. And then the updates, at least for the Raspberry Pi version, are automatic, so it keeps me up to date. And then I'll go into add-ons is really the name of the game. And if you want to see add-ons even without having this installed while I go along, you can do WebThings, api.webthings.io, port 8443/add-on/info, and it shows you all of these add-ons. And what these add-ons do is it takes commercial data or internet services data, takes data from anywhere on the internet or any device and converts it into this standardized W3C, Web of Things, thing descriptions. And then interoperability of rules and so forth is based on having all the data sets in this common framework. So those are our add-ons. So if I go and look at the add-ons I have installed, you can see how I configure them. So the date and time depends on my latitude and longitude, and I can offset some sunrise, sunrise. So I have actually outdoor LED lighting in my front porch that depends on rules of when is sunset. So rather than keep changing the time for the time, you know, as the years change and it gets darker or lighter, I just have the lights go on at sunset and go off at 10 p.m. I never have to change the rule. And then I monitor earthquakes from the USGS online data set, and I can say how far away I want them to look from my house and the magnitude. And so we might get some browser alerts that tell, you know, when there's an earthquake. There was one right before I started this talk, but even 1.0 earthquakes occur like all day long, so we tend to get some. And then the Google Homes, I have a couple of them in my house. They're set on mute, so I don't actually use them for smart assistants at all, or rarely. I might unmute them to do something, but I use them to talk to me. You know, I find that they're just excellent text-to-speech things. So I have all these preset canned things that I have assigned to rules. So if there's an earthquake over 5.0, I want to see where it was and how big it was, and maybe go into the USGS data site. When we're out of the home, I set a rule that there's an intruder alert, and any door that gets opened, you know, the multiple door sensors will present this, you know, loud announcement. You can also set the volume on these announcements of unauthorized persons, you know, must, you know, authority being contacted, which is authority being me, because I get Slack messages through a notification add-on. And then I have a water sensor under my sink, so if there's a leak under there, it will notify me. Porch motion, I usually use that rule off, but sometimes if I'm expecting a package delivery or something, I'll turn that notification on, and then if I'm somewhere, I'm notified that someone came onto the porch. The bad air quality, you know, that's another, you know, wildfire problem we have in California. I have my rules set up for 2022, Happy New Year, but you can have happy birthday, you know, when somebody walks in the door and the door opens, it could wish them a happy birthday. I've done that before for my husband. It's kind of fun. And then I have a couple of things of just be aware, like the leak detection of the garage door left open. I have a little timer set for 5 minutes, and if the garage isn't closed after 5 minutes, then it, you know, just says check the garage door, you know, might have left it open accidentally. The pulse adapter is really cool. You can just create toggles and buttons and things and timeout things for whatever you want. I have this everything pulse, which is always on, and when I turn it off, it turns off all my powered devices like lights in the home. Very convenient. Here's that purple air adapter. Again, it's just saying how many sensors within a kilometer of my home do I want to monitor, and then I can add them to my gateway. Scene control is like red alert lighting. Again, when the intrusion detection triggers, it turns all of my lights on that are smart lights, and then it turns all the colored lights into red. So the whole house lights up, and everything that can be red is red. So that's kind of a fun scene control thing. Scheduler I used a lot for the holidays. You know, I have my Christmas lights and stuff downstairs turn on even before I got out of bed and came downstairs, and you have the whole house is dark and you have the shimmering little lights, and it was really pretty. And I could set the schedule for different days of the week when I get up at different times to make sure they always came on. Slack is just a notification, again, for getting messages directly to my phone. Sonos is the way I play internet streamed music. And the Tide in Redwood City, where I go rowing. They're all, you know, like I say, most of these things are either a station where you're fetching this data or some sort of means for getting these internet services data. It's really cool to bring all of this data into you. And then another one of my favorite adapters, Voco, uses the now acquired by Sonos Snips libraries, but they were open source libraries, and one of the Mozilla developers initially did a demonstration of it, and another guy in the Netherlands picked it up and made it even a lot better. And you basically have a speaker microphone, and you speak to it locally, and it implements these you know, commands, the same commands as I can do through my web interface, I can now do through my voice. And it has some extra things like setting timers and setting something on or off for a certain amount of time. So it's that is just like one of my favorite add-ons. There's another one called Voice Control, but it uses the Mozilla Deep Speech Library. It doesn't actually work as well, so I recommend Voco. And then the weather, again, is just latitude and longitude of where I am. And the WebThing is actually the sort of the standard. And so when I build things with Microblocks, I use the Wi-Fi things show up as just standard WebThings. And then I have a couple other devices, and I use a lot of the battery operated things I use. Almost all of the, probably all of the battery operated things I use are Zigbee, because it's a very good low power, protocol. In fact, I have, you know, right here is a backroom motion sensor. And so that's works really well on battery. So I just mentioned the voice. So before we do anything, I just want to say that I can test, like if you're worried about your voice commands, is it detecting your voice commands correctly, or is it just that the system isn't set up to understand what you're trying to say? So you do need to know the name of the things. And if you know the name of the things, and you can say, so like turn on TV bulb for 1 minute. And I can send that, and that turns into a timed event. And so it says, you know, and she's gonna, little speaker will announce when it goes off. So now we can go over to that area, and at some point this TV bulb is gonna go off. So let's go over here and see, this is the TV bulb that went on. I could, you know, use maybe we'll go over there and we'll change the color of the bulb as the first thing we'll do using my voice. So now, let me just check. Can y'all see? Okay, so you see the screen, and then you'll be able to, I'm gonna show you sensors like right up there. So hopefully I'll do my best. There's an actual door sensor up there for backside door, but now I'm gonna walk you over to the main hub of things, which is the Raspberry Pi. Oh. So she just announced that she was setting the timer back to off. So now we would have to actually go in there. I'm just going to turn it back on again. And then I can say, hey, Snips, turn the TV bulb to orange. Setting bulb to orange. Okay, so now the TV bulb is orange. You can see that this is the TV area motion sensor. So the motion sensor is triggered. And then this is the Google Home that we can pretend that something has happened, like if the garage door was left open.
Check the garage door since it seems to have been left open.
And so that's the type of alert I would get when something like that happens. I could also, if the bad air quality happens.
Check air quality. It's moving from moderate to unhealthy.
And so it just alerts me in significant earthquakes and things like that. And so now we have this TV bulb on. I also have a Sonos connected, and I can say, hey, Snips, turn on the Sonos.
Setting playing of Sonos to hard.
Okay, and so what happens is now this is turned on. And if I walk over here, it's finishing up a commercial, and then you can see, hopefully, the orange of the light. And I also have a physical button. This is an IKEA Zigbee button, so I can turn things on and off, the music on and off with this. I could turn it on and off with the playing button. And right now it's basically just playing Radio Swiss Jazz. And so I can just also turn it on and off just like that. Okay, so that's pretty cool. This, the color of this can be all sorts of different colors. So if I turn it to, let's say, magenta, then you should see it change right there. And then I just want to show you, it's all the simple things that are actually really useful, like the entry door to the house is through this garage door, and it's right here, a Samsung Smartthings sensor. That should be this door right here. And so when I open the door, you see that it shows that it's open and closed. And I can trigger various things based on those actions. And then over here, I have some outdoor, I don't know if you can see, but outdoor cafe lighting out there. And I have this button I could use to turn it on. I don't know if you can see those lights turn on out there. But I can also use my voice even from across the room. I can say, hey, Snips, turn off the string. And she says, setting power string to off, and it turns off. And then I have this virtual button that's everything that just says turn everything off. I click it and all of my lights would go off. So again, there's just going to take you on a quick another little tour of different devices. This is my front door. So if this is open, and I open the front door, you'll see front door active. And then out in the front, actually, this is like the picture of stuff, the picture from the other thing that you saw, and I have strip lighting right down here. These are the LEDs right down in the rocks. And the cool thing about those LEDs is because they're colored, I don't even have to set up lights for different seasons. And Christmas time, I have two strips. One is red, one is green, and Halloween they're orange, and Valentine's Day they're pink, and 4th of July they're red and blue. And so that's the garden lighting, which is somewhere here, down in here. And then here's all my air quality sensors. I have a whole bunch of them. I have my Slack alerts. I have the tide in Redwood City. I have the earthquakes, which right now there's nothing active within 500 kilometers. Let's see. I have like front hall motion sensors. This is a little IKEA one that's firing right now from that. I have a desk lamp that goes on automatically at sunset. I have, buttons scattered throughout the house just for turning things on and off. And I just want to show you a little IP camera. Now the IP camera, I still don't point inside my house because it's Wi-Fi and it's connected to the internet as well. It sits right here. I don't know if you can see that, but it sits in this front laundry room. So, and there's also a tiny little, whoops, I just dropped it. Sorry. Tiny little Zigbee. This is a Xiaomi device that does temperature and humidity. So if the humidity was too much, that might be a problem. So, and then upstairs there's door sensors. There's, if I show you, there's a garage door sensor. Again, I just use a normal door sensor for wanting the garages on and off. This is the outdoor LEDs in the garden. And various powered things. The lamp has a timeout. Other doors. And that's, there's the themes or the scenes that I can set to different things. And And again, the logging of all the data is really, really useful. So I'm going to wrap up with that home tour and make sure I leave some time for questions on that later. But now I'm going to stop sharing that one, and I'm going to instead, and if there are some questions you can ask me interactively, you're welcome to. Otherwise, I'm going to show you how you can easily make your own smart home devices. Hope that was somewhat fun. You can see I've built this home, over a period of time. It's not like I did it all at once. Okay, so now I'm going to share another application, and this is the Microblocks IDE. And so what's going to happen is I have this little device I was playing with like more than a week ago. It's a little servo that I can control the motion of, and it's a little growth sensor. And I don't remember what application I had on here. I was like, what did I have? And so Microblocks has this awesome feature of the blocks are on the microcontroller, and I want to just open from board. Oops, wait. Before I do this, I need to share. Never mind. Okay, share your screen. And let's see. Select window. Blocks and allow. Okay, now I'm sharing Microblocks. Okay, so this IDE again has many languages. You have to get the firmware on a microcontroller once in order to do it. But right now, what I want to do is I want to open from board. And it says to plug in the board. So I'm going to plug in this board right here into one of my USB ports. And it has a little grove sensor, servo. And I plug in the board. Oh, sorry. I plugged in the board from the wrong place. I need to plug it into the microcontroller, not the extra power sensor. Okay, so plug in the board. Whoops, there we go. Now it's reading the project from the board, and it's taking the blocks on the board and basically decompiling them, and should show me the blocks on my screen when it's ready. So how convenient is that? And so now I can look at my code and say, okay, when I press button A, I'm going to move this servo. Well, first of all, down when started, it has a set pin 2 to, or set the servo pin 12 to a certain amount. So if I push the A button, oh, wait, hold on. Push A and then push B, it would move. However, the servo takes a lot of power, and it can't drive it off the 3 volts. So let me just move this back. Now I know what code is written on here. Let me just do a quick experiment here. Now I unplug the device, and it complains. And I have to apply the power to the board that has the servo. Now I know what the code looks like, and I say, okay, press button A, what's going to happen? It spins around. B, it spins one way, and A, it spins another way. And so now I know what this does. And I just want to show you the really cool part about Microblocks is unlike make code or some of these other things, I can do stuff in real time. It's live. And so I'm going to plug in an LED strip here onto another pin. And this time again, I need to plug into the board. And then I say, rather than this servo thing, I'm just going to say new. Get rid of that project. And I'm going to load the NeoPixel library. Again, there's a whole bunch of different libraries for different devices and things. And then I'm plugging it into, I believe there should be 30 LEDs on here attached to pin 2. And let's start that. When started, let's define that. So if that works, then we ought to be able to just say, set all neopixels to green, and lo and behold, they all turned green. And so now you can do all sorts of fun things with them. You can do loops. You can, you know, like do from one to another. I could change the color right here, make them all pink, and just click the block, and it's live. It just does it. And then this actual board has built-in basic sensors, like tilt sensors and the acceleration and so forth. So if I accelerate it more, you'll see those differences. And it has this cool block of graphing or say that you can use. And so you can take these sensors like the light level, and I say, you know, like forever, maybe with a little bit of a wait, 50 milliseconds. Put that inside the block with the say block. So I have the light level here, and now if I cover it, it goes lower and like higher. But in addition to say, I can graph it. So let's duplicate this block and graph it. And then I can have the light level here. I'm going to put 0 at the bottom. And let's see if we can play that. And now, if I cover it, you see that go down. You see it go up. And so now I can look at the light level. And I could do other things, like instead of the light level, I can do the tilt sensors. So let's do X. And then also Y, whoops. I also want to do Y. And let's just clear this. And then I want it back at 0 in the middle. And then I want to forever show X and Y. And now you can tell if I tilt it one way, which sensor, and then if I go this direction, I believe it's the Y parameter. That's the green one. And then this one is X. And then Z is flipping all the way around. So they're actually a 3-axis motion sensor. And then if I shake it, you'll see the. So there's libraries like for step counts, step counting, and all sorts of cool things. And so this is a really fun, absolutely like coolest thing in the world because it's so live. Like the first thing you do in Arduino is you blink an LED. So this has a little LED light that you can turn on and off, and I can just do that. And if I could just pull these blocks out, and forever I can turn the LED on, maybe wait 200 milliseconds, duplicate these 2 blocks to turn it off, and then, when started. And this is essentially Arduino Blink. But of course, if I wanted to make it more fun, I do the LED display instead of just one LED. I pull this part out, and now I should be doing a happy face blink. Oops, wait. Instead of, so I can just change it in real time. When I realize I make a mistake, clear display instead. We'll pull that out. So now it's doing the happy face blink. And so you can realize how easy it is to do these things. And then the libraries for WebThings, going back to IoT, is under network. There's this WebThings library, and I click that, and I open it. And it has a library of things that basically do all of that JSON description behind the scenes for you. And so now I have, I set a thing name. I set a capability like a light. So let's call this a Microblocks thing and a light. And I can just give it a Boolean property like I have to define at least one variable. So I add a variable called on, and then, you know, I set on to, you know, true or false for starters, something like this. And I could even do the LED strip, for example, to be on or off. And then I give this title on, and then I start the WebThings server. And then all I would have to do is, like, wherever this becomes a if. So this becomes if on. I grab the on variable. If on, I'm going to set all of the pixels to pink. Else, I'm going to clear the neopixels. So we need an else here. Else if clear neopixels. And then I get rid of all this other stuff. And so now, and just to be able to test it, let's do a little control. So when button A is pressed, let's toggle on to the opposite of itself. So let's toggle on, oops, to not on. Not variables. Sorry, it's hard to do all this one-handed while I'm holding this. But now, basically, if I start this program, it creates a web thing, and I toggle the button, and it goes from on, which it started, to not on. And so now there's my toggle, my button. And then at the same time, if I were just to look at the WebThing JSON, let's see, there's a thing description here. If I look at that, this is what the description in JavaScript is, and I can connect this to the Raspberry Pi and run the Microblocks add-on. This doesn't have Wi-Fi, but I could do a radio remote control to one of them connected to the Pi and then the other one remote, and I have lots of these things. And I could do servo motions to open or close something. I could do lights. I can do motion detection. I could connect one to a door. And so you can use these microcontrollers to basically create all of the different web things that I showed you from my commercial devices. And so I just wanted to show you a few of these other devices that I've built as web things. This is a WebThing IR controller, and it's a little this is the M5 stick C, and so it has a little user interface display, and then I can use a remote control to toggle it. This is, I have a couple more microbits that I just turn. One I use for temperature and light, and one I use for the lighting going on and off, just as a button press. This is another bright LED that I use for things. I have my own indoor air quality sensor that I have hooked up to a Wi-Fi device. So this is also programmed using Microblocks as a native device. This I have set up, this is called an M5 stack, and it has a motion sensor, PIR sensor connected to it. So I put this somewhere, and this is a battery, built-in battery, so it can run for a little while, not forever. I usually leave it hooked up to a battery brick. And so all this fun stuff basically becomes build your own IoT devices. And then I also have, I'm sorry I don't have it set up, but I had all those devices hooked up to this Raspberry Pi, which also has a Pimoroni blinked Pi hat on it, so I can do individual colored lights on the Raspberry Pi that's running the WebThings Gateway directly. And the way you set these things up is just a micro SD card. You flash it with an image, you plug it in, you boot it on your network, you connect it to your local Wi-Fi, you give it a domain name so that you can access it remotely, and then boom, you're ready to go. So the last thing I'll mention here of the Microblocks is there's all sorts of cool, fun games and library. If you look, you know, under the microbit and the Calliope boards, you find tons of fun games you can play with it, as well as music and all sorts of things. So I have tons of different examples. There's also, just so you know, Web of Things has its own examples of how you can set this thing up as a heart rate monitor, temperature and light, push button, hello, LED, ambulance, lots of different things. So in fact, if we do the ambulance thing, I'll just show you really quick before I stop sharing this. This has the ambulance basically uses the, let's say that we do the 30 LEDs on pin 2, and then attach the buzzer, I think is on pin 0. And let's see if we can play that. So the red blocks are basically setting it up as a web thing, and then I have button A to toggle it on and off. So this is my little ambulance. And then toggle that. And so this actually works as a web thing. And I will stop sharing that.
Okay, Kathy.
Yeah.
You have a few questions. If you can reply to them in the sharing notes on the left side of the screen.
Okay. Let me see.
The remaining few minutes, if you can.
All right. So in the remaining minutes, let me go over to the chat window. Is that where I'm supposed to be?
Yes. Shared notes.
No, public chat or just shared notes? Shared notes?
Yes.
Okay. I'm going to the shared notes right now. Questions for me. Okay. Tour of my, that is, have you written documentations or reviews of these different systems? Not really. You know, documentation, there is the wiki, or WebThings Project will take you to the wiki, and there's some documentation about devices we know to work. And my base recommendation is look up some of the information. If it's a Wi-Fi device, you have to be very careful about whether or not it's getting out to the internet or not, and block it. But Zigbee or Z-Wave devices or anything that's non-IP is going to be good. And then look at the add-ons, because they will tell you a lot of information about the different devices. Is there any major implication when IPv6 becomes the standard in terms of security embedded systems? Again, IPv6, you're going to have to treat it just like Wi-Fi or anything that has an internet accessible protocol. Then you have to know that you're blocking that device from the internet or not. And I think in future versions of the WebThings, there's one guy that's set up the Raspberry Pi Gateway as the access point, so all the Wi-Fi devices connect to it. And then he has an add-on that basically blocks them unless he wants them to talk to the internet. You know, there are future applications where you have an appliance and something breaks. You want the appliance manufacturer to be able to remotely check the information, but it's something you just want to turn on for the time of that, you know, remote service call, not always monitoring what you're washing in your washing machine, right? And so it really depends on the protocols to investigate that. What's your opinion for, is Tor hidden service the perfect tool for exposing IoT home server behind? So the current encrypted channel that I'm using it's PageKite. And so it is tunneled just to me, HTTPS only for my username. So I'm fairly confident with that. But it does have a cost. And right now that cost is being bared by volunteers, and we're trying to turn it into a nonprofit that can cover those costs. There's another tunneling service called NKN, which is a blockchain distributed service, and that does work also, but it's a little cumbersome to set up. So I'm hoping we can add an add-on that you could use the NKN tunneling, or you can just, you know, you can open a port through your own broadband service provider. You just have to be very careful who has access to get into that port. Let's see. Besides encrypted channel, only you know the service. Automatically hacking attacks simply don't know where is your exposed server. No one should know you have a smart home, right? Yeah, I totally agree. The smart home privacy to me is very important. And what worries me most about these centralized service providers having access to all our smart home data is like one hack exposes millions of homes. At least in the case of decentralization, where each of our homes is a data center, they have to hack into one home at a time, just like physically they'd have to hack into one home at a time. And if you're in Russia, you know, physically accessing my home is pretty hard, and but remote access is easier. So I just have to maintain that security of HTTPS from the outside as the only way to get in. Are there IoT devices talking in a proprietary protocol? Well, yeah. So how does WebThings deal with it? Any wireless protocol or messaging protocol that's proprietary is fine, as long as at some point there's an API that's exposed or can be, you know, reverse engineered into getting those data. Now, there are some that are like Nest, which is like a secure pipe from the device to the internet, the Nest internet and back. You can't tap into it. There's no Nest add-on because Nest does not expose any information locally. And it's a real pain to get it from the cloud. What are your opinions of the Home Assistant project? So I've built one. It wasn't hard to spin up, but I found that I didn't spend a lot of time on it because it requires all these like TOML configuration files, and I really felt like the WebThings is something I could set up in my mom's home and my cousins and my friends and family, and it really doesn't require any configuration files that are difficult. Like they can then learn just the add-on config file is just a web page, and they don't have to learn special things. So for Home Assistant, it's great for, there's a lot of flexibility for developers, but not a lot of flexibility for non-tech people, is my sense. Maybe it's improved since I last tried. And then data explosion. Do you think that, quote, data explosion happens when we save this data, typically in a cloud, should our devices be more forgetful? Yes, absolutely.
I would like to add something to this question. I saw a little bit earlier the detail of the data logs in one of your slides, and in the perspective of a non-technical user, that is a huge amount of data that is being saved. I'm not sure if in a cloud or in our laptops or something like that. What would be your opinion about all these concerns about privacy and data leakage and
right. For myself,
information being sold in black market?
Yeah, I don't want my data saved over time. I have a 7-day rolling window where the data just purges and rolls off. There is like an InfluxDB add-on. So if you're an industrial setting or a commercial setting, you might want to store data, but you might want to do it as a what are those RDB, the sort of where it crunches the data the older it gets, might be a way to log it. I personally, for smart home use, I think you should throw it away unless there's some real good reason to keep track of it. And someone else wrote an add-on, Timon in the Netherlands, where you can actually set up periods of time where it's not logging data from a privacy standpoint. Like when my housekeeping service is home, I don't want to keep track of everything while they're in here. And so I just have it not logging during those times. And so I think we really need to enable consumers to keep very careful track of what is being logged and the privacy implications. There's a lot of things to be done.
Absolutely. Thank you.
And then what other cloud services can we use other than Google Cloud to potentiate the features and usability? Oh, well, I don't think we need to use commercial clouds at all. In my case, I think we should all be our own clouds and run things locally. And other online services, even if you trust the vendor of it, the vendor can get hacked as well. So you have to be careful. Is there a way to set up a secondary Pi to take over in case the main one will fail? Yeah, it's as easy as just backing up this certain WebThings IO directory. I back that up periodically, and then you can just bring up a brand new Pi and just upload that directory, and your whole Pi is back to normal. So there's also satellites that someone has done for the voice control, so you can have satellite voice control in different rooms. Any hardware kit already pre-installed? Yes, OKDo actually has, OKDo.com has a WebThings Gateway Raspberry Pi 4 kit, but it's only the Raspberry Pi part. And then on top of that, I would just get a Zigbee adapter and a bunch of Zigbee devices you can buy from IKEA or anything. Can you show add-on for a cat? We use Microblocks to write it. I don't have time to show a cat, and I don't know what you wanted exactly, but Microblocks for writing your own IoT devices is really cool. It's super fun. I highly encourage people to play around with it, and there's a wiki on Microblocks that has a little information about how to set up the Raspberry Pi Gateway, and then a few basic WebThings applications you can write with it. So, sorry I blabbed too much and ran out of my time, but I hope you got some fun out of it.